In this video, we're going to create bar charts with error bars. We're going to do that in Excel. But in order to get the data for Excel, we're going to go to SPSS and compute it. Now I have the vision data set here, and I am going to set a filter so that we get just the last visit. Before, I had written a filter and then I saved it under ref status because we want our status to be the myopic status and the study year equal to the last study year. So that's our last visit and the last status that the person had as a subject in this longitudinal study. So in order to do that, I'm going to go Data, Select Cases, If Condition is Filter. Okay. And then we can look at our data and we see we have tons of people cut out. Do we have anybody that was not cut out? I'm sure there are some. There's one. Okay. So we want to compute means. And let's look at before in order to get separate means, what we've done is split the file and done descriptives. I'm going to show you another quick and easy way, quick and dirty way to get means. I'm going to go to compare means, a one-way ANOVA. We're going to ask for ref status. And let's say we're going to do refractive error. So let's find refractive error in here. Spherical equivalence. The variable name is ref error. Let's go to options. We want descriptives. And that should do it. Let's hit continue. What this gives us is a one-way analysis of variance. We see that there is a difference between myope, emmetrope, and hyperope for refractive error. Not surprising there. And then here we have the mean, standard deviation, standard error, and so forth for each of our conditions. Now what I like to do is on my computer is to cut it down, have half the screen be the output, and then, oops, really annoying that it does that all the time, but anyway. And then open up Excel. And we're going to get a blank screen. We're going to make that smaller. Bring it over here. And now we have our Excel over on this side and the output of SPSS on the left. We're just going to Control C or copy, and then we're going to paste. Now when you paste, you have two options. If you choose the one on the left, you get those lines, and that sometimes is kind of annoying, and cells are merged, and that can give you headaches as you're going through this sometimes. So I prefer to use the copy on the right here, which just gives you individual cells. It doesn't merge anything. It keeps everything where it was, and it just makes it nice and neat. Now, our goal is to create a bar chart, and we're going to, for these different conditions, for the means. Now, one thing we can do is just highlight like this. I think I'll do it this way. So we'll highlight the groups and the sample sizes. We're only doing these two so we can quick and easy insert a graph, and then we'll move from the samples to the means. So let's look and see how we do this. Go to Insert, and then we pick out a chart. It calls it a column or a bar chart. We have highlighted the numbers we want to capture. So we click. There's a number of we can do 3D. I don't like 3D. Don't use 3D. The reason you don't want to use 3D is because you don't know where that line is actually crossing. It can be, see there's space down there, so it's not really right, it's not above because there's distance in there. It's a very misleading kind of graph, and I would avoid it. Sure, it looks cool, but it's not worth it for the loss in precision that you get. So let's insert our bar chart. You can also do it sideways. You can do a stacked bar. I'm not a fan of stacked bars either. You can also do something where you cover 100% of the numbers in different groups. So we would get these things that all add up to the same height. That's pretty useless. I think just the straight out clustered column bar is what we want. In this case, we don't really have a cluster because we just have one condition. Now, you'll notice we have our chart here, and we have the bars. They're labeled, but they're sample size. So we don't want that. We want mean. So we're just going to drag that over there. And here we go. And in this particular case, these are basically diopters, and they go in different directions. Now, see how myopes are covered by the bar? If we come over here, now we can make this the full screen. Let's come over here and let's amend this axis. So we right click, we format the axis, we come down here to labels, and right now it's next to the axis. Let's make it low. That puts the labels down at the bottom, so nobody's covered up. There are a couple options here. We could also go high if we wanted to put them up there, but pretty much everybody puts them low. So we can stick them down there. The other thing that's just kind of a pet peeve of mine, I don't like all this white space. It's just, they should be, either we should scrunch in the chart, or we should make these bars maybe a little wider. So let's highlight them and see how it has gap width. Let's reduce the gap width down to around 50% or 66. Those almost look a little too wide, so they're a little boxy, so maybe a little more than that. But here we have now some nice labels. You know, in SPSS, when you're futzing with the font size, you have to go in and do them separately. It's really kind of a pain. But in Excel, you can just go home up here and hit the big A to make the font size bigger in general. We're not going to put a title in on this one, I don't think, although we could. We could click that and call this refractive error. The other thing we can do is we don't have to label our x-axis, but we want to label our y-axis, and these are diopters. And so we go to Design under Chart Tools up here, go to Design, add a chart element, make it a title. We have horizontal, which is along the x-axis or vertical. Click on that, and then we type in the number up here in this label line. We don't have to go over here. We could, but it's easier there. And we can say refractive error in diopters. And if we do that, we don't really need the title up here that says refractive error. So you can just delete that. Notice it automatically adjusts everything. And it's all good. Now right now the bars are blue. Blue is okay. You can go into this fill, and then you can say you want to make the border around those lines black. Do that. See, did I do it? Black. And then make the line a little thicker maybe. It's pretty hard to see that with a, whoops. I am formatting the plot area. That's the problem. Well, you see how to do that. Let's Control Z. All right, let's try that again. Let's go to our lines. Let's do a solid fill first. Let's give ourselves a little bit, maybe gray. And now let's do a solid line border, make it black, and increase the size of that line. And we get, that's too big. We get a nice little border there. Okay, now one of the things you always like to do is put in error bars, and we'll talk about confidence limits and 84% confidence intervals and stuff like that later. But right now, virtually everybody sticks error bars, just standard error, the standard error right here. Now, how do we do that? Well, we click in here, which would be more necessary if we had two groups. This way, there's only the one line, so it's not too, we don't have to identify it quite so clearly. But let's go in, add a chart element again, go down to error bars, go down to, we don't want this standard error. I don't even know what that is. I don't know if it, I just don't know what that is. It's not what we want. We go to more error bar options. We come over here. We go to click on this little symbol to make sure we're in the error bar options and the and we come down and we click on custom, specify our values, and we have positive error bars and we have negative error bar values. And both are right here, the standard error. So we're going to do a plus standard error, and we're going to do a minus standard error, same numbers. Okay. And you can see that's a pretty small number. And that's because our N is so big. And it kind of gets buried in here. Sometimes what you might want to do is make those that fill a little lighter so you can see them better. And you might not, that one you can't even see because it's so small. This is probably not the best example. We could, instead of standard error, since it's so small, click on that guy, specify the values, and instead of standard error, we could put in standard deviation, the positive and the negative. Okay. Yeah, now those are kind of big, but they still bring out the point where you can get, but remember this is just one standard deviation. And so you're covering, if the data were normally distributed, you would be covering 68% of potential observations. Really not that great. You can see the variances aren't exactly equal, so our assumption in our analysis of variance of homogeneity of variance, which means they're all the same, probably not too accurate. This is kind of an interesting problem because in analysis of variance we do want to have kind of similar distributions in terms of width and shape. And if we were to do a box plot or look at our histograms of this, we would find this one skews in the direction to the right, and this one skews in the direction to the left. And the emmetropes are kind of normally distributed. It's a very weird distribution. The saving grace for this is that the sample size is so large. So nonparametrics really don't buy you anything, even though you're not meeting the assumption of equal variance. But that's for another topic. All right, that's how you create means and error bars. I think that's gonna do it for this topic.